So this presentation is on the power of solid history, and we're really going to be focused on the ability to use solid history to create our toolpaths and modify our toolpaths. And we're going to talk about some tips and other automations as well. So we're going to start with kind of an explanation of what is solid history, just so we are all kind of on the same page with that. And I need to talk about the difference between solid tools versus model prep tools, because there is a big difference in the way that those two things work, even though we can get a lot of the same results out of them. I have a quick tip for you on how to extrude multiple cuts or bosses at the same time. That can save you a lot of time depending on what you're designing. We want to talk about how to modify features with solid history and how we can use that to update our toolpaths automatically. We're going to have a quick discussion on the difference between associative and incremental linking parameters, because it does play a role in what we're talking about today. I also want to talk about whole segments, because whole segments are awesome, and I think it's an underutilized function in Mastercam. We're going to wrap this up by talking about how to add your own solid history. So if you are in a shop where you don't make your own models, you get them from engineers, fear not, there are things you can do to add history back into your model and still be able to use a lot of these tools. Not all of them, but over time we'll see how that goes. And then we're going to finish up with defining toolpaths at different points within the solid history. There's actually some really cool things you can do if you know how to manipulate Mastercam the right way. So let's start with a quick discussion on what is solid history. This is essentially a record of all the changes that were made to a base solid model. So if we take a look at this image right here under my solids menu, you'll see that I have one solid body at the top, and then there's all of these sub items in here. This is the solid history. It's basically saying everything that we have done to modify some body in some way. The items in the solid history relate to the wireframe that we use to create those modifications. This is for extrusions, cuts, bosses, holes, revolves, lofts, and sweeps, and more. We can also take existing solid edges and we can add things like fillets, chamfers. We can pattern different features. We can shell out models, and we can draft things to, we can add draft to walls. So all of these things are considered solid history. The tools that we use to make modifications to a solid that would have history tied to them are found within the solids tab of Mastercam. So when you're looking at the top, there's all those tabs, and there's two of them that have solid tools in them, and the solids tab is the one we're really focused on. There is another tab called Model Prep that also modifies solid models, but it doesn't work in the same way. They are not solid history based. So what is the difference with model prep tools, as shown here? These are called direct solid editing tools. So they don't keep a history like the solid tools do. And this means that you can visually change your model by selecting the correct faces and moving them. You can stretch them, you can change them by pushing and pulling, or selecting an edge and turning that into a chamfer or a fillet. This is a very graphical way of modifying your solid, but it doesn't have that history associated with it. When you have toolpaths that are tied to solid models, and you use model prep tools to modify that solid, your toolpath can still update. But it doesn't allow for what I like to call a cascade effect, which we're going to see in just a minute here. And the reason for this is we can't use certain tools in Mastercam when we modify our features without history. There is a reason we have this, though. When you get models in from other systems, you won't have solid history to play around with and modify. You'll have to use model prep tools for a lot of the changes that you want to make in a model. And like I said, we're going to go over adding history as well, but you can't necessarily add history for everything in a solid model that was given to you from a different system. So this is the set of tools that you would use to make changes in that kind of scenario. So it's really useful there. All right, so the first thing I want to start off with is just a quick tip for you on extruding multiple cuts or bosses. So if you are, let's say you're making a part and you have multiple chains and you're going to make a cut from that, or you're going to make bosses from that, there is a checkbox that is often overlooked inside of the solid extrude tool that will allow us to change the way that this behaves on kind of a base level. Depending on whether this is on or off, we get totally different results. And I really like this for family of parts, and I also like it for making a large number of changes to a model all at once. So let's take a look at how I have this set up in Mastercam to kind of show you what I mean. So this is a pretty basic part. I just have a cylinder here, and I have 3 wireframe profiles that I want to extrude out. So if I go to my solids, extrude, and I'm in my wireframe chain, I'm going to select all 3 of these chains. So let's make the assumption that I want all of these to match, and they're always going to match, right? We can green check here, set this to cut body, flip direction, and let's call it a 1/2 inch for now. So all 3 of these pockets are a 1/2 inch deep, following all 3 of those chains. By default in Mastercam, this checkbox for create a single operation is turned on. And that means when I green check here, we're looking in the solids manager now. And if we look at the second solid body in the list, which I'm highlighting now, we can see there's the body, which is the original piece, and then there's the extrude cut. And there's 1 solid history item there. So that is really useful if I always need to change all 3 of these pockets at the same time. If all of them need to be put at a different depth, I can double click on the extrude cut and change my distance, right? So now they're 5/8. So that's a good way to do that. But consider this. What if you have these 3 pockets and maybe they start the same for this part, but in a family of parts, there's actually different versions of this where the pockets are at different depths. The traditional way to go about this would be to run the extrude operation 3 times to get 3 different items in the solid history tree. What I'm going to do instead, I'm highlighting extrude cut, and I'm going to use delete on my keyboard to delete that out. And then this button highlighted here is to regen the solid. So we're kind of back to the starting point. I'm going to reopen extrude and chain in the same 3 chains. If we uncheck the box for create a single operation, then what happens is the initial extrusion will still have all 3 of those chains extruding to the same depth. But when we look in the solid history, we now have 3 separate extrude cuts. This means that I can go back and modify these individually. So even if I have this big array where I have all of these different pockets and they all kind of have different depths, you could still chain them all at once, turn off that checkbox, and you could at least start with a bunch of operations. Then, once you have something selected in this tree, you can use your arrow keys on your keyboard to light up those features to see which one you're looking at. So it's just a cool thing to do to kind of speed things up a little bit. It's a little bit of automation. You don't have to individually chain everything. So the next thing I want to talk about is kind of the big thing here. This is going to be modifying your features with solid history. When we have everything tied to a solid history, it means that we can make modifications to that history and it changes our part automatically. And there's a couple ways we can do this. We can either modify our chain if we want to change the profile of something we've done, or we can change the solid feature settings itself. So in this example, I'm going to show you a couple of different changes, and we're going to see how we can modify our toolpath output quickly and easily. So this happens to be in a dot machine mill turn environment, but it really doesn't matter. It can be anywhere. We're just talking about the modeling aspect of it and the way that toolpaths can chain to that. Let's simplify this a little bit. Just kind of take a look at this. And in my solid tree, I have a single solid body with a whole bunch of operations here in the solid history. Now, right now we have these pockets that I'm highlighting here, and maybe in a family of parts, these pockets get modified depending on which part you're making. In this case, if I analyze this edge, this shows up at 0.875 wide. But maybe we have a version of this that is an inch wide. We can modify our wireframe that made that solid history, and we can change the model. Now, here's something else I want to point out before I make changes. I also have a toolpath here. This is a dynamic peel mill that is tied to this model. The chaining for this is based off of the solid model itself. So if I open the chains, you'll see how it's lit up like that. So now if I go back to my solids, right, and I open up my other view sheet, I can see the wireframe that was used to create that feature. I'm going to modify this so that we can have a wider feature there. Now, in order to make sure I get that right, what I'm going to do is I'm going to open up a quick C-plane. So in the planes here, if you click on the drop down for new plane, you'll find quick C-plane. Or, I use it so much, I put it on my right click menu. You can select on any flat face and it creates a new plane that's a temporary plane. It'll sit there just long enough for you to kind of do what you need to do. This plane, the orientation of it might be kind of weird with the X and Y, but I'm really not concerned about that. I'm concerned about the Z direction so that I'm normal to that, because I'm going to modify this wireframe. And I want to make sure that I'm modifying it in that plane. So to change this, all I'm going to do is double click on the side here. And then I have, if I hover over the blue dot in the middle, I get this arrow. So if I'm equally spacing this out both directions, I would set this to 0.0625 one direction, because we're doing 125 total. Click over here, do the same thing. This is going to be a negative number. We just need to reconnect the endpoints here. So I'm going to select on the end and bring it to the endpoint. Okay. Once I'm done with that, I can hit escape. Now our solid hasn't updated yet because we need to tell it to regenerate that solid. If I go into my solids manager, you'll see that we have a couple of broken pieces of our solid history. We can click the regen button and that will regenerate the solid to fit the new wireframe profile. Another thing that's pretty cool is the way that this part is designed. Because the feature is repeating at a regular interval around the part, I didn't actually design this wireframe on all sides of the part. I only designed it here. We used a pattern to get the other features in. So that means as we kind of roll around the part, this one is actually a pattern of the first, and so is the next one. That means I only have to change one feature to change the entire part. The toolpaths also went dirty because I changed the model. But I can hit regen here, and all of the toolpaths have been updated. If we take a look at the original toolpath, which was number 9, I can unghost it for a moment. We can see that the new version of the toolpath, because it's tied to the solid, is already compensated for the new solid geometry. It's going to come back and do a finish pass here. That's why I didn't get to the edges. So that makes it really easy for us to modify our toolpath just based on changing the solid history. The other features on this part were handled with transform operations. So I also didn't have to update more than one thing, just one thing, and everything kind of picks up on its own. So that's a really simple way to show changing the size of the solid and the feature itself to update your toolpath automatically. We're going to come right back to this, but I want to show you something else. The depth is another part of the feature that we need to consider. We only changed the width in that example, but I need to also be able to change depth, and Mastercam can do this. The trick here is to make sure that we're using the correct linking parameters. We have to make sure that we are using associative or incremental linking parameters so that it can follow that solid edge. This will allow you a lot of flexibility compared to absolute, because when you program something to absolute, it will only program to that value relative to your WCS, right? Whereas when we are doing it this way with incremental or associative, it will actually follow the features. Now, there is a difference between incremental and associative, and it's important that we point that out. I'm going to go back in, modify this once just to show you how it works. Then I have a different example to show you the difference between incremental and associative. So back in my solids manager, we just messed with the flat a minute ago, and the next feature down is the flat pocket. So I'm going to open that, and the distance here is set to 0.25. Now the relative point to that is actually up at the wireframe, so it's not 0.25 deep from this floor. But let's say that I know that it needs to go an extra 50 thousandths. I can set this to 0.3, and that'll push that pocket down farther. Now, if I hit the blue check, that will actually regenerate the solid automatically. So it has updated that pocket as well as the pattern that updates the rest of the pockets on the part. The toolpaths will again go dirty because in the toolpath that controls that pocket, which is number 10, if we take a look in the parameters, linking parameters, we'll see that the depth was set to an incremental 0. So when you have depth at incremental 0, that's following the chain height, the chain Z. Because the chain has actually moved since we adjusted the solid model, we don't need to do anything to change the linking parameters. It can follow that for us. Now, the difference here is that we have other settings on here set to associative. And that's because we want them to be associated to the top of this feature. If I set them to incremental and I increase the depth by 50 thousandths, my top of stock, if that was incremental, would also drop 50 thousandths, right? And we don't want that. We want it to be associative to the top of the feature instead. It's because of the way that the incremental relationship works. The top of stock is incremental to the depth, and then the clearance, retract, and feed plane are incremental to the top of stock. So that's the relationship of how incremental works. Associative is always associated to the point on the model that you select. So even if that point moves, that can be updated. So again, it doesn't make a big difference in depth, but it does make a difference in the other settings. One other quick thing I wanted to show you. Let's say that this has another version where we have 4 of those features, not 3. This is really easy to change because since I used a pattern, I can double click into the pattern operations and simply change the number of instances. If I set this to 3 on a full circle and regenerate, it will automatically reset those features. Now I have it 3 separate times in here, so I'd have to do it 3 times. But once we have those all set, we now have 4 of those feature sets around the part. Then all I would need to do is go into my transforms and in the rotary settings, switch this to 3 instances at 90, since they're equally spaced. Now I'm going to get this error for source regen, and that's okay. I'm just going to kind of skip through it because we can do it all at once at the end. Otherwise, we're just doing it over and over again, extra regen time. I can regenerate everything at once with a single click. And now I have a 4-flat version of this part with new pockets and holes, and it took very little effort to get here. So that's where we can really see the power of using our solid history and using things like transform for repeating features. It gives us a lot of flexibility. Now I have another example to show you a visual example of incremental versus associative. Right, this is an extremely simple example, but it does a great job of showing exactly what's happening. So I have 2 drilling operations that are basically the same thing. The only difference is the way the linking parameters are set. In the first one, I am using all incremental settings. So my depth and my top of stock are both incremental 0. And that works because I'm using this top checkbox for calculate incremental values from holes and lines. And I am not using calculate depth from top of line / hole at the bottom. The retract incremental height is incremental to top of stock, as well as the clearance. That's also incremental to top of stock. The associative settings, even though this toolpath looks identical, we're using associative for clearance specifically. And this is associated to the top of the model. The reason that's important is if this model changes its height in the middle without changing the outsides, we can have a problem. So let's go to our solids manager and go to my original block. I'm going to change this to a 2-inch height. Now, if we regenerate that, our toolpaths will go dirty. And when we regenerate this, this actually shows the problem. You can see how in the incremental setting, our clearance is no longer high enough to get across the top because that's incremental to top of stock, not incremental to any point we actually selected. Even if we use this button to select our clearance height, it doesn't mean it's tied to that point when we're using incremental. It's measuring the distance in Z from the point you select to the top of stock. Associative will follow that point on the solid model itself. That's why it can get enough clearance to get over this part. So, which one do you use? Well, a lot of times you can get away with just using incremental, and that will be fine. It's a little bit easier to set up, and it's a little quicker. But associative does have its place, and it's very powerful. It just takes an extra couple of clicks because you do have to select a point, and then you need to set a value. And this value is, this is kind of confusing, but the value here is incremental from your associative point. All right, that's the trick. So here I'm at 50 thousandths. That's 50 thousandths above my associated point. So, and another thing I wanted to point out, just because some people have said this before, and I wanted to just mention it here. If you use incremental here, this does not mean it's going to output incremental for code. This is not going to output G91 just because we set incremental here. It's a way to measure our linking parameters here in Mastercam. It has nothing to do with the output necessarily. All right, so the next thing I wanted to talk about was hole segments. This is a feature that was added into Mastercam, I think in 2022, I believe. And it's a feature that I don't think gets enough attention. It's not utilized. And the only reason I would say that is I also help Jeff with support, and I get files in from customers, and I never see anyone using this. But I think that there's a lot of power in it if you know how to use it effectively. So I kind of wanted to talk about this a little bit because it is tied to solid history. It's important to note that if you want to use hole segments in your parameters for a Holemaking toolpath, you have to have the entity defined as a hole, not an extrusion. There is a difference between those two. So if you're in a situation where you have round holes, consider using the hole tool in Mastercam rather than the extrude tool, because it's going to give you more flexibility. So in this part, I'm mostly going to be focused on the 1/4-20 counterbore holes here. These are for some socket head cap screws. And I know there's 3 toolpaths here, but I'm mostly going to be talking about the last one. Let's go ahead and set up all the geometry though. So when I make my selection, instead of selecting a point or an edge of the circle, I want to select the entire whole body itself. Now there's a couple ways you can do this. You can double click on a hole and it will actually find the entire whole body. Note that this has a name, top 1/4-inch socket head cap screw. And the reason it has a name is because that's the name that is given to it in the solid history. Now that's not automatic. I named them that way. So when you are making your solid history, consider naming your various history events, because it does help clarify things down the line. I can also right click here, delete, and if I hold Control, then double click, it's going to find all of the holes that are part of that solid history in that particular item in the solid history. So all 4 of those holes were made at the same time, and they share one line in the solid history. That's why they're all selected. These 2 on the end are the same geometry, but because they're in a different plane, they have a different item number in the solid history. So it's important to know that those will not show up if we do this, right? Which is good. If I don't have a multi-axis machine, I'm not trying to cut that anyways. Finally, another way you can do this is if you go down to the solids manager, you can actually find on the left-hand side, all of the different items in the solid history, and you can just select it, and that will pick those for you. You can go back to your toolpath hole definition, and they're all selected. Okay, so a few ways to make your selection. Also, make sure to pay attention to this drop down here. There's a lot of neat tips in there for how to make your selections. So I'm going to green check there. Then I'm going to drag and drop this geometry down for all of the operations and regenerate. Now I already have my linking parameters all kind of preset, so this was fairly automatic, but that's not really what I'm interested in. What I am interested in is operation 3 parameters. If we take a look at the hole segments, which are below tool axis control and above linking parameters, this is where we can tell Mastercam what parts of that hole are we interested in looking at when we take our linking parameters into account. So in this case, because I'm making a counterbore with my end mill, I'm not concerned about the through diameter of the hole right there. I'm only interested in the counterbore and the top chamfer. The top chamfer because it will have to do with my top of stock. When I go to my linking parameters, it means I can be very fast and loose with this. I have a depth of incremental 0, top of stock of incremental 0, and then my feed plane and retract are both just set enough to kind of get out of the way. I'm also using the top checkbox for calculate incremental values from holes and lines. So with that, it means it's actually following the solid history of that counterbore. This means if I go back to my solid history and double click on the original hole operation, I could change the depth of that counterbore. Let's say that for a version of this part, they need to be further recessed. So I'll set this to like 450, right? As soon as I enter, those counterbores will drop. You see them drop a little bit farther there. I can blue check to allow that, and the toolpath will go dirty. So I need to regenerate them. But we can see that the depth of that counterbore has updated automatically because it's following the hole history itself. And this is really useful if you have a big array of holes too. One of the customers I was just working with the other week, they were working on this plate where they have a whole bunch of holes in it and a bunch of them are counterbored. By setting everything up as holes instead and using those hole segments, it allowed very quick changes to this part by simply changing one parameter in the hole definition. And it updated all of the toolpaths and the model automatically. And you can do this in a couple of seconds, as opposed to the crazy amount of work it could be if you have these separated out and you're not using these features. And imagine if they're on different heights or something, that could be even worse. Now, I did want to point out that there is a slight flaw with this. If we go back to the Solids Manager and reopen the hole definition, while we can change the depth in Mastercam 2023, changing the diameter actually breaks this. It will lose that associativity to the hole history. The good news is that I've tested this in 2024 and it does work fine. So that's good. That's just another reason to stay on maintenance and make sure you're staying on the most recent release, because there's lots of great features that come out every year. And by staying up to date on that and staying up to date on any updates that are put out for Mastercam, you will get the most for your software that you're paying for, right? So keep that in mind. It's definitely good to try to keep up. We do have the ability to add history to models. There are two tools in Mastercam for doing this. We have Find Holes and Add History. In older versions of Mastercam, these were actually one function, and they've been split off because they work a little bit better when they're separated. There is some limited application to this, but we'll find that what we have right now is great for a lot of instances, and over time, they might beef up these features so that they can do more and more. So the main benefit here is being able to add history back in if you get a model from an outside source. So let's go back to Mastercam and I'll show you kind of a simple example of this. So I'm going to blow away my toolpaths just because all the associativity and everything, I'm going to get a bunch of warnings. If I go to my model prep tab and then select remove history and selection, if I now go back to my solids manager and open up the solid, you'll see that we only have a body. So this is what would come in if you were getting this from a different system. We can add those holes back in really easily by using Find Holes in the Model Prep tab. This is one of the rare exceptions where I said all the history tools are in the Solids tab. Well, except for this one and Add History. Those happen to be in the Model Prep tab. So with Find Holes, we have the option to create hole operations with the first option here. And there's also a checkbox for create a single operation. Kind of going back to the beginning of this presentation where we were talking about the multiple chains, this behaves in much the same way. If multiple holes can be defined by a single operation, it will combine them into one. Or if you uncheck it, they will be separate, right? So same concept. Whether or not you want them separate, that's up to you and what you're trying to do. I'm going to leave this turned on. The body has been pre-selected because it's the only one on screen. And I'm going to set my maximum radius bigger, like 2.5 inches, so that it can get to everything on this part. Now, if I green check here, it's going to tell me that it found 32 holes in one body. It'll even find things that are out of plane. So those two counterbores on the right-hand side of the screen that are in a different plane, it'll find those and it'll associate that to the correct plane for that operation. Now we can see in the solid body history, we have a counterbore, we have another couple of counterbore holes. There's 3 different simple holes because they have different depths. And then we have our counterbore holes on the outside. We have that history back. Now it won't put the name the same way that I had it before. Again, I manually name those. So you can right click on the names there and you can choose the rename option to give it a different name if you want to do that. But it's a really useful tool when you're programming and you're getting models from another system if you want to use some of these solid history features and tools in Mastercam. All right, so the last thing that I wanted to talk about today was the ability to define your toolpaths at different points within your solid history. If you've been looking at the solid history during this presentation, you might have noticed that there is a stop op button down at the bottom of the solid history. This has to do with where we are inputting our toolpaths relative to the solid history in order. With this tool, it means what we can do is essentially ignore certain solid features and toolpath around them. This is really cool for certain circumstances where you have a well-defined history and you need to ignore certain features. There are other ways to do this, like adding in surfaces for avoidance, creating boundaries, things like that. But this is yet another way that you can do it, and it's dynamic because if that solid history changes, your toolpaths can update automatically. So before we can get into this really cool thing I want to show you, we do have to double check a setting inside of Mastercam that allows us to use this super neat trick. You can find this inside of the File tab, go down to Configuration, or use Alt plus F8, and then go to the Solids page. There's a checkbox here for Add New Operations before trailing toolpath operations. We need to make sure that this checkbox is turned on in order to use this particular feature. Without this turned on, this is not going to work. Now, I do believe that this setting is on by default, so if you haven't messed with it, then it should be fine. Okay, this is a very simplistic example, but it does a good job of explaining how this works. This block is mostly green, and then I have some blue faces and some red faces. Now, essentially, the reason they're colored is just for visual purposes. But you can imagine that the blue faces here, they're tangent to each other. So if we were to extend those out, they would actually match up in the middle. The red face is kind of an interruption. And what I want to do is program around that red face as if it wasn't there and the blue faces were connected. We can do that by modifying the position of the stop op in the solid history. So I'm going to start this by dragging it all the way to the top where it says block. That's actually going to bring us back to the initial block shape where this started before we added in these other extrusions. I can use this for, say, my facing toolpath. I can go into my geometry, right click and add, and select the face, green check, and regenerate. And that's now tied to that solid face as if there were no other operations done to that solid model. Now granted, facing is probably the most cherry-picked example you could have because you don't even technically need to do that. If you don't select any chains, it will just follow the job setup stock boundary. So if that matches, then we didn't need to. But if it doesn't match for some reason, maybe you can't get it to define well or something, this is another way to take care of that. It gets more interesting in the next operation. This is a dynamic mill toolpath, and again, I'm going to ignore those red faces. So to do that, we go back to our solids manager. I'm going to take the stop op and bring it down one spot. And so now we can see the extrusion without those red faces. Now the blue faces aren't showing, but those green corners are the same thing. In the toolpaths now, I can go back to my chaining for my op2 and set up my chains. I'm going to use a machining region of the outside profile. And my avoidance region will be the profile of the inner boss. Green check and regenerate. So from a top view, if I run this in backplot and I have my quick verify turned on, we can see what this toolpath will look like. So it's ignoring those red faces because essentially it doesn't see them at this point in the solid history. I'm going to set up the next contour with the same chains. So I'm going to add a new chain, loop around the bottom of the boss, and regenerate. Now, the reason I'm wanting to ignore those faces, I have a 1/2 inch tool here, and the red cutouts, if you measure the radius in there, it's a 1/4 inch radius, or exactly half. So I don't really want to drive my big tool into this small feature. I'd rather use a smaller tool for that. So I'm going to come back in with a smaller tool, my 1/4 inch, and this one will work on the entire solid with all of the extrusions in there. So we're back to the model state. So here in my geometry, I'm only going to set up an avoidance region. It's going to assume the boundary for everything else and regenerate. So this is pretty close to what I want. You can see how it's digging into the red corners, and that's what I am looking for here. But there is also some wasted movement. You can see how on the sides of everything, it's got all these extra passes. We can ignore that by going into the parameters. And then in the stock page, if we turn on rest material for all groups, then regenerate, it's going to ignore all of that area because it sees that it's already been milled based on the previous toolpaths. So now if I run these 3 toolpaths together in backplot with my quick verify, by the way, if you haven't seen quick verify, or simple verify is what it's actually called. It's one of the buttons in the backplot manager up here. It's just to the left of the exclamation point. But if we run that, turn off the holder for some clarity, that's the result that we're going to get. So really cool. Another way that we can take advantage of the tools in Mastercam to program this really effectively and efficiently by only looking at the features that we want to machine. So with all that said, there are so many things we can do in Mastercam to leverage our solid history as part of our toolpaths and link those things together to make things like family of parts, prototyping, or rapid development much simpler and easier.